Quadrilaterals. Quadrilaterals are closed geometric figures with 4 sides and 4 vertices. So we learned in 6.1 that when we have 4-sided figures, the sum of the interior angles are going to be 360 degrees. And we could use the formula to find it, but this is one of those ones, just like triangles we memorize add to 180, quadrilaterals add to 360. Now, there are many different types of quadrilaterals, as you can see listed in this diagram, and we're going to discuss all of these types throughout this chapter. But for today, we're going to just discuss quadrilaterals in general and parallelograms. For our first example, it says that we are going to find the missing measure if we are given 3 of these measures. So we want some quadrilateral. It says we're going to call it ABC. So just some random 4-sided shape. We'll call it A, B, C, D. We always go in a circle as we label them. And they are 90 degrees, 120 degrees, and 40 degrees. And we want to find the third angle. So we can call that third angle X. Fourth angle X. Now we just said they all add to 360. So let's add them up and set them equal to 360. So we have 90 plus 120 plus 40 plus X is equal to 360. That adds to 250 plus X is equal to 360. So when I subtract, I'm going to get 110 degrees for my missing angle. In the next example, we're given another quadrilateral. It is called KLMN, and it says that angle K is 2X, angle L is 2X minus 20, angle M is X, and angle N is 3X plus 20. Again, we know they all add to 360. So 2X plus 2X minus 20 plus X plus 3X plus 20 is going to equal 360. 2X and 2X makes 4X, 5X and another 3 makes 8X. Minus 20 and plus 20 actually makes 0, so 8X is equal to 360. That gives us that X is equal to 45. However, the question didn't just ask for X in this case. It asked for the measure of each angle, so we need to plug in that 45 to each of these angles. So the measure of angle M, that's easy. That's just going to be 45. For angle L, that's 2 times 45 minus 20, and you're going to get 70. 2X, so that's 2 times 45, which is 90. And lastly, 3X minus 20, so 3 times plus 20 is going to give us 155. And sure enough, if I add those yellow measures together, they should give me 360. So one of our types of quadrilaterals, and the most common, is a parallelogram. Parallelograms are, if you see right in the word, have the word parallel, and that comes from the fact that their opposite sides are parallel. So AD is going to be parallel to BC. When we draw those little arrows indicating that they are parallel, they're headed that kind of same direction. We also know the other opposite sides, AB and DC, are parallel to each other. So opposite sides are parallel. We also have another rule that our opposite sides are congruent. So AD and BC not only are parallel, but are the same length. And AB and CD are not only parallel, but the same length. And then we have a few rules about the angles. So our opposite angles are congruent. So angle B and angle D are the same measure. Angle A and angle C are the same measure. We also know that if we add consecutive angles together, they are supplementary. So in this case, for example, if we said the measure of angle A plus the measure of angle B, that would equal 180 degrees. Or we could say that the measure of angle B plus the measure of angle C is equal to 180. Or really anything that would be consecutive. So if I were to start kind of following the letters in a circle, the next one that would come up. Consecutive really just means what's coming up next or what's next to. Last but not least, I can draw diagonals here. So if I were to draw diagonals through my parallelogram, meaning connecting opposite corners together, there's one diagonal. Let's see how straight I can draw. Here's another diagonal. Our diagonals bisect each other. So this side of BD is congruent to this side. And this side of AC is congruent to this side. So they're going to bisect each other. So what we can do is use those rules to solve for missing parts. So in this case, all these examples we see, we just want to find what the variables are equal to. So in number 1, we see that opposite sides are congruent. And that's the rule we're going to have to use here. So a plus 14 should equal 6a plus 4. And then we can also say that b, or 9b plus 8, is going to equal 10b plus 1. And we'll have to solve those. So I'm going to subtract a. I'll get 5a plus 4 on the right. Subtract 4. And I'll get that a is equal to 2. For b, I'm going to subtract the 9b from both sides. Subtract the 1. So I'm going to get that b is equal to 7. Okay, and that's just using that rule that opposite sides are congruent. For this next one, we're talking about angles. So I know 2 things about our angles. I know that opposite angles are congruent. So that means that angle y and angle, well, the angle that's measuring y degrees and the angle that's measuring 44 degrees are going to be equal to each other. So y equals 44. I also know that consecutive angles are supplementary. So they add to 180. So that means if I were to add x and y, or if I were to add x and 44, they should give me 180. So x plus 44 is going to equal 180. And when I subtract 44 from both sides, I'm going to get that x is equal to 136. Last but not least, I'm talking about my diagonals. So I have a rule about diagonals that says diagonals bisect, meaning they cut each other in half. So this half is equal to this half. So x minus 2 is equal to 19. And this half is equal to this half. Y plus 1 equals 26. And now I can solve those two. So I'll add 2. That's x is equal to 21. I'll subtract 1. I get y equals 25. And those are our basic rules that we have to follow when working with parallelograms.